Dr. Anna Motta, Research and Development Manager at Talga, the high-tech materials company. Professor Dusan Losic, Head of the Australian Research Council's Hub on Graphene-Enabled Industry Transformation. Dr. Maria Smolander, leader of the Flagship's work package for flexible electronics, and Luca Banszerus, researcher into novel electronic nanodevices. First, to our keynote speakers. Now, despite suggestions from history that it takes decades or maybe even centuries to transform discoveries into applications and products, graphene is already out there as a result of the Graphene Flagship and its partners, though there is, of course, still so much research potential. Our first keynote speaker founded 2 startups. He's brought products to market for Nokia, and he said, graphene has the potential to shift entire industries. Please welcome the Graphene Flagship's Head of Innovation, Dr. Kari Hjelt.
So welcome all. Good to see so many faces here. So let's get down to the presentation. So first of all, I would like to say that we are now halfway in the Graphene Flagship, and we are progressing as planned. And that is a small miracle, I would say, in this complex of a project with so many stakeholders and so many different countries and companies and institutes involved. But I'm very proud to say that we are progressing as planned. So just to look a little bit backwards first, the consortium is at the moment constituting of about 155 partners, which 40% are universities, 40% of companies, and 20% of institutions, and in 22 countries in Europe. So quite an undertaking indeed. So in the ramp-up phase, the number of partners was increased from 74 to 142. In Core 1, reaching until 2018, we had 156 partners. Now in Core 2, which will last until the end of March next year, we have 150 partners, and the number will be a little bit increased in the last part of the present plan for Core 3 with 160 partners. And of course, on top of this, we have a lot of national projects that are connected, regional projects and other European Union projects which are connected to this one. So what we see now that the European Commission funding until the end of this project, or program rather, will be about 401 million euros. And we are then looking forward to the next program, Horizon Europe, to extend maybe a little bit further as well. So to also say that many of the times we talk, okay, what is Europe doing with the 1 billion euro invested in this? I would just like to say that until this date, we have invested from the European Commission money and the taxpayers' money, we have invested 209 million euros. So it's really, in a way, just in the beginning. And a lot of things has to be done still before we can even say that we are halfway in the spending-wise. So this was the original sort of thinking or wishing process, what the flagship could achieve in the 10 years. So what is the process going through the roadmap of this kind of undertaking in 10 years' time? It's very difficult to prognose these kind of things, especially in a long time frame. But where we are now in the halfway through, we have actually achieved most of the predictions as we planned them in the beginning. So we have shifted from the academic research towards more industries. The amount of industrial work share is growing steadily and will be growing even more in Core 3. The academic work share is very important, but the amount of that is reducing in connection when you compare it to industrial work share. We have also shifted from understanding and looking and researching the material and production techniques towards understanding what kind of components can we really achieve with this new material. And then now we are beginning with the real system integration exercise, which is another level, of course, from the components. We really have to understand how graphene and related components are really brought in the systems, like telecommunication, like aeronautics, and so forth. If you just look at the numbers, in all the major key performance indicators, we are doing very well. So all the green numbers are green for the reason, so it means that we are good. So the number of publications is, of course, astonishing, and this is not a wonder because it's such a new, exciting new material, but also that in the first half way through, of course, a lot of the work has been academic, oriented to discoveries of the new properties, but more than 3,100 publications. The number of citations is as astonishing, over 85,000 citations in the Web of Science. Number of patents, it's over what we expected, but I would like to say that we try to boost this number even more in the future, because I think now it's time for really look at the industrial usage and the patenting in that sense in Europe for sure. So this is something that we try to work on. We are very proud to say that we have already products on market. So the current number is a little bit shifting all the time, but it's about 30 products that are commercially available to buy on the market, ranging from all kinds of materials, inks, and so forth, to real products. I will actually show some examples in the end. We have also been involved in creating 9 spin-offs, so that's a good number for such a young project. And I think this is the last number, the number of small and medium-sized enterprises participating in our events, Graphene Connects, 139 separate SMEs. It's a good number. It shows that there's a real interest of the industry also on this scale towards our endeavors. Just some highlights. This is sort of almost tradition, a yearly highlight, the Mobile World Congress. Also this year, it was very important to us to have visibility and PR for our work. It's a huge conference, of course, in the telecommunication area, but nowadays it has enlarged itself to contain Internet of Things, even the sort of car manufacturers, because everything is connected nowadays. So it's not mobile anymore, it's really everything connected. And everything seems to be starting to be connected. So in a way, that's actually a very good platform for us to present our results. More than 110,000 visitors and a huge media coverage. And just to show the importance of the future, importance of the graphene, what the industry sees us as beneficial for their future plans, I think the good sign for is that they actually support us with giving this kind of a large space for exhibition of the graphene. It's called Graphene Pavilion. And Mobile World Congress really supports us with the space, so we don't have to pay for that one ourselves. So I hope this continues, but let's see. Another example of a very good event, a new kind of event that we have been running through is so-called Graphene Marketplace. The first one was held in Italy, Milan, 17th of October last year, and it was in collaboration with the Graphene Flagship partner Leonardo. And of course, Leonardo is a very big corporation, and it takes graphene very serious, as you can see. A very nice event, really highlighting the prospects of graphene in their business, which is actually ranged in many industry areas. So these 2 examples have been about outreach. So we have also boosted the outreach activities in the flagship by creating a business developer function. So there's 8 business developers in distributed places in Europe, all having different areas to cover and different responsibility application areas. I'm not going through them, but it's just to show some examples that you'll actually find Graphene Innovation Forum 3 days, today, tomorrow, and Thursday, On Wednesday, there will be a Graphene Innovation Forum upstairs, so you can find more. About the evolution. So in the future, we will now actually make very soon decisions of funding experimental pilot line for devices based on graphene, related layered materials, and heterostructures. And this will be at about 20 million euro, a little bit less than that, put in this kind of a new pilot line. So this will be work done on this year to decide which is the consortium to work on this pilot line. We are increasing the number of companies. From the beginning, it was 15%. Now, in the core 3, it will reach 48% of the partners are companies. I think this is a huge achievement. Then we are planning beyond Graphene Flagship, as we know, or have the plans at the moment, to extend to the horizon Europe. And then also a very important tool for reaching all this is that we have 11 spearheads selected for the core 3. So the 11 spearheads are, I will not go them through, but they are, as you see, in the areas that are very important for the Europe. It's aerospace, automotives, optoelectronics, aviation, health and safety even is one of the spearheads. So we really have a very nice spread of important areas for Europe. And with the big companies like ABB, BMW, Airbus, and so forth. Very quick run of some examples of the products that we have at the moment. So there's this G-Next coating. So they have invented a way to make a very large area coating for polymers, polymeric films. So this can be, of course, used in packaging and many industrial applications. There's an air cooling unit that actually, by using graphene in its structure, achieves superior efficiency compared to competitors. That's by Nanesa. Then there's Emberion optical sensors, which actually have very broad infrared sensor wavelength area for, of course, many different application areas. But this is basically a CMOS sensor that has been enhanced with the graphene layers. So this is something new that actually shows the power of graphene in the optical sensors. Then Extron is making this first roll-to-roll graphene production machine. So that is actually very interesting development as well. Versarion has been showing these new types of earphones that are much better than any other competitor when it comes to the producing the high and low tones because of the material properties of graphene, which makes the thinner and more flexible speakers. And then almost last but not least is this thermal rubber. So rubber is not usually very thermally conductive, but inducing graphene in the rubber makes it thermally more conductive. And of course, it has a multitude of applications. That's made by Avanzare. So to bridge this presentation to the next one, because the next presentator will be from Airbus. It's also very, very nice work what we do with the Airbus. We have shown that by introducing graphene in the parts of the wing structure, that can be actually reducing the weight and of the wing, but also enhancing the mechanical properties simultaneously. And this is very interesting and important development by the Airbus and us, and the group Antolin and Aeronova. So with that, I would conclude my presentation. Thank you.
Truly astonishing achievements by the flagship. And who knew that with all this, less than half the budget's been spent? I think you better hurry up and spend a bit more. As Dr. Hjelt said, partnerships with industry is very important, Airbus being one of them, and our second keynote speaker is a senior scientist and project manager for surface technology at Airbus. Please welcome Dr. Elmar Bonoccurso.
Thank you, Jane. Hello, everybody. Okay, that's the presentation already. Yes, as Kari said, so like we are on the other side, so we are on the side of the people who, or companies who would like to use graphene. And I tried to give you a very brief flavor of how we plan to do this. And especially as what concerns next generation materials, we plan, or we have plans and projects to apply this in structures. So all the part of aircraft or helicopters, which makes this structure of the product, but also on surfaces, surface technology, coatings, but also systems. And I will just give you some flavor of this. So I think everybody knows that on the European side, we are one of the largest, say, European companies. We are based in 4 countries, and so that's a very nice project by itself, Airbus, which is going on since 50 years now. So this year we have our 50th anniversary, and we are strong on the side of large passenger aircraft, of helicopters, but also in the military and in the space business. Though we have reached now the 50th anniversary, but I think especially in these last years, we all recognize that, excuse me, especially concerning mobility, concerning transport, concerning traveling, we have very strong challenges to face. And one of them is for air transport to reduce the environmental footprint, so to become greener. But the other part is really go towards more smarter mobility concepts, so sustainable and smart mobility, so to get people from one place to the other at lowest cost, especially for the environment. If you already look at some of the achievements that the aviation industry has reached over the past years, we have reduced fuel burn, which is of course responsible for most of the emissions, CO2 and NOx. And we also have reduced noise. The airports are usually close to large cities, and noise is definitely something which is absolutely disturbing, if not also causing diseases. So there has been some progress. We still have some targets that we want to reach. There's the program 2050, where we still want to continue cutting and reducing emissions of CO2, of NOx, but also continue in reducing the noise. How do we do this? So we have a whole lot of people, engineers, scientists, working on the innovation side, and we also launch internal projects in various areas. As I said, one of them is definitely the way of moving people around, but also some very basic things like the materials, like aircraft is made in the first place out of materials. And so we have chosen, and we change them quite regularly, we have chosen some priorities, and you see them here. So we have definitely electrification is one of them, so reducing the footprint of fossil fuels. We want to go into the direction of making flight more autonomous, to connect, especially then if we go into urban air mobility, to have the fleet which is connected, so we know exactly where all the vehicles are at any time, and they communicate with each other. But the one which is of concern here, when we talk about graphene and the revolution that graphene is supposed to bring along, is advanced materials. And also in advanced materials, we have launched recently a so-called fast track, which means investing resources to push new developments, especially in this area. And one of them is the emerging materials area. And here, just in order just to give you, to dive a bit into the detail of our daily work, is the so-called Project Nanocarbon, where graphene is now the most important component of. And so the reason why we need to put up a structure like this, a project structure like this, is that, I mean, we are 140,000 people, and we need to find a way of having all of them working towards some common goals. And so we created this emerging materials cluster in order to be able to quickly find and identify new technologies, new emerging markets, new emerging technologies, and also to get connected to the external R&D community. So we are by ourselves, we are more engineers, we build things, but the fundamental developments, we have to rely on the academic partners which are out of Airbus. What do we work on? Like, what are the materials which are of concern to us? And these are composites. So all main part of an aircraft now is made out of composites. Before it was metals. We go more to composite side because of weight and because of strength also. Still metals and ceramics we cannot do without. Surface technology. We don't want that an aircraft rusts so it needs to stand various climates worldwide. Additive manufacturing, 3D printing, and also testing in a non-invasive way. So like being able to check a very big aircraft, the health of the aircraft during time. So how we do this implementation? And so at first there was this idea of nanocarbon, then we presented it to various boards, and it was developed, and we got finally the go, the approval. And so now we are also, by participating to the Graphene Flagship, in a position that we can show internally that we have also the right partnership to do this and to get quickly to the results that we would like to have. Usually when we do this, every time that we think that there is something coming up, so we focus usually on some long-term applications, and this is also what materials in aerospace are. So specifically, as I said, the categories of materials where we think that graphene can give a very strong contribution are those which I have already addressed before. And what do we want to do with this? Like, new materials is okay, but also we still have to use old materials, but we want to improve the functions and the properties of these older materials. Like, graphene can help us in reinforcing mechanical properties of some of the materials that we use, be it metals, be it ceramics, be it polymers. From a structural point of view, but also from a surface technological point of view. Same holds for electrical conductivity. So an aircraft has a whole electrical network which keeps every part of the aircraft, which is quite big, at the same potential, because we want to avoid this for safety reasons. And so we need to have conductive materials. Once we had metals, this was not an issue. Now with composites, with polymers, they are not conductive, and so we need to compensate for this. Graphene would be the perfect material of choice for this. Same holds for thermal conductivity, like also going in the field of electrification. Batteries produce a lot of heat, and you might realize when you use your cell phone, when you charge it, when you discharge it, so this heats up a lot. So what to do with all this heat which is generated? We need to dissipate it in a smart way. And also for electrostatic or electromagnetic properties. So we need to shield some parts of the aircraft, of helicopters and so on. And the application, so once we have improved the properties of these materials, of course, we need to go into looking for applications, so real products. And this is then more the system part, which I was talking about. And here we have also examples on lightning strike protection, low observability if you want to go in stealth mode, the electrostructural network and so on. And so you see we have a whole bunch of material properties that we need to improve and of applications in mind where we're really looking forward to the contribution of graphene. I think I can, well, this is just the challenges that lie ahead. I guess all of you know we need to be able to produce more graphene, good quality, standardized. It needs to respect all the environmental regulations that we have. And so there's quite some work still to be done. The start has been done. We are happy to be part of it. And so we're looking forward to the next period altogether. So thank you very much for your attention.
Before you go, from your point of view, Airbus has developed a very good partnership with the flagship. How should companies approach doing business with the flagship? What tip would you offer?
That's a very good point. I think there's no just one solution, but definitely send out scouts, send people also to the Graphene Flagship meetings and to see also what the potentials could be. I mean, first of all, we need to know that there is something which we can use and which you can use and where we can work with. And so that's definitely one point. And the other one, I think we are really in a good position that also the public bodies are offering these resources to fundamental science, but also to companies. So companies can, of course, profit from the value that is generated. So definitely go out and look, go to congresses, go to conferences, and talk to people.
Dr. Elmer Bonoccurso, thank you very much indeed.
Thank you, Jane.
Thank you. Well, now we're going to hear from our eminent panel of experts. Would you please join me on stage as I introduce you? Professor Jari Kinaret, who's director of the Graphene Flagship, the scientist who led the bid for funding from the EU. He wrote once that he had apparently 5 minutes to deliver a speech at one stage, but then they chopped him off after 3 minutes. Well, must have been the best 3 minutes, that's all I can say. Dr. Anna Motta, who is Finnish, so she's home. She has long experience with graphene, especially at the Cambridge Graphene Centre. Now she's transferred her skills to research and development at Talga, overseeing work on coatings, composites, energy storage and construction. Professor Dusan Losic. The Graphene Flagship is Europe's largest research initiative, and it recognises the importance of forging links not only in Europe but around the world. So our guest from Australia is a very good example, and he links researchers with industrial partners. He's chairing the Australian-European workshops. Dr. Maria Smolander, of VTT, the partner organisation hosting the Graphene Week. She's an expert in wearables, and she's also the work package leader on flexible electronics. But importantly, she is also on the Graphene Flagship board, where decisions are taken on how the Graphene Flagship develops. And Luca Banszerus. He came to the attention of Graphene Week when he won the Best Poster presentation in 2015, which gave him free access to Graphene Week. He used the Graphene Flagship bursary to do research at Harvard, and he's now back at his home university, Aachen. Welcome all. Can I ask you all, first of all or some, how big an impact could graphene make on society and our economy? Who would like to? Jari.
Well, there are several estimates on that. And the estimates vary by several orders of magnitude, which shows the difficulty of your question. It's something that I don't really know how to put in numbers. I see that we have impacts in many different areas, all the way from automotive to medical technologies to electronics. Composite materials. Some are maturing faster, some are taking a longer time to reach to the market. So it's other than saying that the impact will be large, I think it will be difficult to quantify.
Anybody like to add to that? Okay, let me look at environmental advances. Now, I'm reading about particularly the importance of climate change and the impact that's having on us all. Graphene is being worked on for batteries, for solar panels, for desalination, and we're hearing from Airbus about energy storage and wear resistance. Where can we go next, and how important do you think environmental concerns are?
Yeah, I think this is a very, very important area, and there are several opportunities in graphene in this field. So we also can make conductors from graphene and also graphene-based sensors, and I think all of these have a great impact on sustainability and climate change as well, together with those which you already mentioned, the powering and so on.
I think it's also important to remember that we can also replace very environmentally unfriendly materials, and we can improve recyclability in many cases. So there's a lot of different aspects to sustainability.
Can you suggest some examples where that might happen?
For example, if you have layer structures with the carbon-based materials, and then you maybe have a barrier film of metal in the middle, when you're trying to recycle that, it's very difficult to remove these from one another. But if your barrier film is made out of carbon, you can recycle them together with your other components.
And
I'd like to highlight there are many big problems to be addressed that cost our society trillions of dollars every year. I will point a few, for example, anti-corrosion coating that costs trillions of dollars. Our industry is based on toxic materials. Fire retardants coating that cost a lot of lives, a lot of impact on also industry is also based on toxic materials. Anti-biofouling coating is also using toxic material that costs also in industry huge amount of money. In graphene, based on many unique property, can address this problem, and I think this is huge opportunity for graphene materials and graphene development, new advanced paint to be used in this industry and make impact for society and industry as well.
which do you think is its most important property, graphene?
Barrier property of graphene are unmatchable with any other materials. He can prevent that oxygen come there for fire resistance, and also he can prevent corrosion, and also graphene has some antibacterial property that will prevent formation of biofilms. And also provide some other combination of new property which are in need, for example, self-cleaning and so on.
I would maybe say that the most interesting property of graphene, or most important property of graphene, is that it has so many interesting properties. Everything from mechanical strength to electrical thermal conductivity, transparency. So it's the fact that there are so many things that you can combine and build upon together that makes the material unique.
The EU awarded a €1 billion budget in 2013, I believe. It's got 10 years to run. For any skeptics that might be out there, how would you begin to persuade the public that they're getting value for money? Yes, Luca.
I mean, in the end, graphene is an extremely young material, right? So you have to consider it's 15 years old only. And if you consider, or if you think about the devices which are currently being realized already in the lab, and the huge discrepancy or the huge potential we still have from devices which are currently making their way towards applications, and what could even be possible by improving material quality, I think that's quite convincing even for skeptics to realize we're just hitting the tip of the iceberg, and there's a lot more to do with graphene also in terms of applications once material quality improves.
Anyone like to add to the value for money question?
I sort of feel that falls a little bit
Jari?
on my shoulders. I think there are certain things that you can only do on the large scale. Things like we do now, introducing our validation service, where we can get independent validation and characterization of things. Things that Kari talked about, the activities that we use to boost innovation. A smaller project would just not be able to do those kinds of things. Sometimes quantity does indeed have a quality of its own in research as well.
And I do believe that the access to such a varied and wide-ranging research has enabled the industries to approach a material that is still very young, because there is this collective push and access to so much information and expertise. So I think that maybe it would be a slower progress. Maybe we would catch up later on, but I don't think we would be as advanced with the material development if it wasn't for that.
People must be patient. Maria?
Exactly the same. I think the business development work, what is taking place in the flagship is really great, and linking the research with the industrial activities.
How can we measure success halfway through the project? Is it in the 30 products that Kari talked about, or is it in the prospects that are being opened up for partnerships within the flagship? What do you suggest is a good way of measuring? Maria, any ideas?
Difficult. The products, IP are very, very important, but also the connections between the different partners. Publications, of course, joint publications.
Yes.
We have many different ways of measuring success and progress. The problem is that many of them take a long time to mature. So, for instance, you could measure how many patents we file, but that's an uninteresting number, because if you give me 100,000 euros, I can file a patent. And the more interesting thing is to see how many jobs we create, how many new products are in the market, where do the graduate students go from the flagship and contribute to the growth of the companies. So, and those kinds of things take a very long time to measure. So,
is there any idea how many jobs have been created already? Is it in the thousands? Could it be more than that?
Well, I mean, we know that there are more than 1,000 individuals working in the flagship alone. But how many are working on graphene-related things outside we don't have exact numbers of that.
But I suppose ultimately Airbus is a good example where they're looking to promote the use of graphene in a whole host of areas. So that must open up potential, mustn't it? And Luca?
Sure, but in the end, all you can do right now is kind of do a worst-case approximation of the success of the flagship, right? I mean, you never really know what will come out of research that has been funded by the flagship. If you consider, for example, quite recent experiments where it has been shown that graphene can be superconducting, and it might be even possible to use that superconductivity to really understand physically what's going on, and maybe find other materials. The holy grail is, of course, room temperature superconductivity, where you would basically drop heat or energy dissipation by quite a lot. So it's kind of hard to measure success after 5 years if you have experiments that might impact after quite a long time.
I'm sorry to inflict that question on them, but we're all thinking about money and economy, aren't we? Your funding is to 2023. What then? Does it all stop?
We know that it won't stop. I mean, there is a European Parliament decision that the activities of the Graphene Flagship will be continued in Horizon Europe, as Thomas Kordas mentioned this morning. There are some question marks. We don't know the funding that we will have in Horizon Europe. We don't know the duration, and we don't know in which way the flagship activities will be implemented. But we know that they will continue. So just about the only thing we know is that 2023 is not the end.
And for observers of the flagship and its partners, what's the best way for industry to get involved, Dusan? You're in Australia, you're looking at, I think you have 6 partnerships with industry already. Yes. How have you managed to get them on board?
They come to us because based on our outstanding research in this area, they come with some idea how they wanted to use graphene for develop new products. And most of graphene research in Australia is driven by Graphite Explorer. So they actually wanted to use mineral resources and translate them in new materials. So we've been in position to develop a graphene manufacturing process, which is now establish a plant with capacity of 100 tons per year. And actually they register graphene materials and now supplying graphene materials to Europe, which is really good news.
And I suppose, Anna, that's your field, isn't it?
Absolutely.
At Talga.
Absolutely, and that's what I feel is one of the key aspects going forward, is that there are very steady industrial scale supply of materials, so that the end users can then have the confidence in building their products around the material. Because so far there's been maybe lots of smaller suppliers, but I think that this will be changing in the next few years significantly.
Before we ask for questions from the floor, can I ask you, Asia, China, India are making great scientific and economic advances. Do you see them as rivals or partners? Are they going to run off with all the best ideas, or are we going to go into partnership?
I think it's a combination of both. The Graphene Flagship has international workshops, not only with Australia, but also with China, Korea, Japan, and the US. So we clearly collaborate, but these international workshops predominantly focus on the academic domain. When it comes to industries, undoubtedly there is competition, healthy competition, I hope.
How can the sector have confidence? I think you've mentioned some of the approaches. How can the industry have confidence in standards and the consistency of materials? Because I'll ask Luca first, how important is that for you in your research?
I think for us, standards are not super important yet, but material quality is. So since we fabricate our material all by ourselves, we do have control over this. But as soon as you want to scale, for example, nano devices up to an industrial scale, you need large area material and you need extremely high quality material. And in the end, the definition of graphene, at least in the early years, was quite shaky. Some people would give you 20 nanometer thick pieces of graphite and call it graphene, which maybe if you think about mechanical properties is still partially true. However, if you look at purely electronic properties, it's essentially a chunk of graphite. And I think the flagship has made significant contributions to manifesting industrial standards. So if you sell graphene with a certain standard, people know what kind of product you're going to get.
And that's a particular interest to the flagship, isn't it? To
of course, we
set standards.
Yeah, we are quite active in standardization activities. We have a Graphene Flagship Standardization Committee. A lot of the work in that area is led by Karlsruhe Institute of Technology, very actively in various international standardization bodies. And then we have the validation service that I mentioned, because one of the problems that the field has had in the past years is variable quality of a material, variable from supplier to supplier, but also variable in time from the same supplier. And it's important to establish reproducibility, because other than, if you don't have reproducibility, you can't really build an industry out of it. So that's certainly one of the focus areas that we have.
Anna? One of the topics that was raised by Airbus earlier was that a big challenge for the industry is to tailor the material to suit the application. I think that is something that we all probably know about, and it's not one material that fits all. And just building that confidence of knowing what material it is that is the best for my application, and how I need to handle it, how I need to chemically treat it maybe, in order for it to bring out the best. So graphene is more than one.
Luca.
I think another point is probably also fabrication or processing techniques that play a role. And along these lines, I think it was probably a very smart idea to publish this graphene fabrication or technology white book. I think it came online last week, where there has been, or basically it's a huge document where groups from, or different parties from the flagship document in which way they treat their graphene, how they produce materials, and share the results. So one can really get an overview of which technique leads to which result. And since it's such a new material, it's quite important to figure out what works and what doesn't.
Okay, I'm going to throw it open to the audience now. Who would like a question? If you would like to play with the idea of what your crazy prediction about the future of graphene might be, that we'd be happy to entertain. Anybody have a question they particularly would like to ask our experts? Because I can carry on if you have. You see, you've blinded them. They're entirely happy with everything you're doing. Yes? Oh, yes. Microphone here.
Can I have my name is Jima from University of South Australia. Can I have a question regarding what is the prediction of the graphene cost? Maybe I should say graphene made by CVD, graphene oxide, reduced graphene oxide, blah, blah. We have a few types of graphenes. What would be the prediction of the cost reduction and whether which kind of cost can be acceptable by our industrial partners? Thank you.
So, did I understand you correctly? Predictions for the costs, is that right?
Yeah, I wonder whether any of you can say something, comment regarding the cost. What is the current cost of graphene? Yeah,
I can maybe start because I started the concept of more than one material. So a composite material might have a very different material that you introduce to it, or you would have a very different graphene that you need to put in electronics. So there are multiple price points for sure. There is some thought that at the lower end, like multi-layered graphenes would probably reach $20–30. Okay.
How many layer, multi-layer? Can you tell us the average thickness of the cutting line?
That would probably be from 5 to 30 layers or something like this.
Okay.
Yeah. So, but this is at the very, very low end, and where it's used as a filler to replace something currently existing, and maybe not that much of a performance advantage, but maybe more advantage on the circular economy. Answers for the CVD end. What's the top end?
Well, from the CVD, the one thing that I can say is that earlier this summer, one of our partners, Extron, introduced a machine that cut down the cost of CVD graphene by a factor of 100. And after that statement, I do not dare give any price points. You know, it looks that the price point is varying very rapidly. So maybe Ken is in better position.
For CVD graphene, we're currently producing now at, let's say, about $50 to $100 per square meter. But right now, on our roadmap, we're working on technologies that will get it down to about $1 per square meter. Okay.
Price coming down all the time. Get it now while you can. Oops.
If I can add this regarding price will also depend on application. So if graphene will be used to replace as additive other materials, it's competing with carbon black or somewhere. If improving property for some percentage, that always the balance of price with for end user, what they're looking to get. But I think another advantage for graphene is to build new materials where function of graphene is most important, where more than 50% of graphene used. That will be new materials with high value, and then graphene price will be, it's less important for us. But price in general will go down by time.
How many people work in labs at the moment in the audience? Do you want to show me your hands up? Oh, some, yes, quite a few. Is anybody worried about the toxicity of graphene? When we're thinking about patches, wearables, Maria, should we be worried? Should the general public be worried in the future about toxicity? Is the flagship aware of those concerns?
Yeah, and I think it's one of the advantages of such a great program that we are able to examine that aspect as well, and it will benefit all the activities which are related to health and safety of graphene. So I think it's very good, and it's a great point to take into account.
Is research going into toxicity? I mean, there's inhaling is a concern too, perhaps, as well as the skin contact?
There is quite a lot of research going into that. We have a specific work package dedicated to health and environmental effects that look at different exposure routes. We next spring will start a new spearhead project that looks at health and safety aspects relating to a number of specific technological applications. So it is certainly an area that we are pursuing very actively. And it's also an area where international collaboration is positive. It's not it's in everybody's interest to look into those things, and there is a relatively little competitive aspect in that. So.
And from the industrial side, Anna, do you're aware of concerns and are presumably looking into them?
Well, absolutely. It's something that we keep a very close eye on all the developments in this area. We in the company work mainly on applications where the material is in a matrix, where exposure is much limited because it's sort of bound in maybe a polymeric system. So this is often maybe a positive way forward where exposure is not so critical. But yes, of course, it's an important topic.
I suppose any other questions? Oh yes, one there at the side, if someone can get a microphone to you, sir.
This is an open forum, so if I may, I'd like to broaden the discussion a bit. A cynic might say that with a budget of €1 billion, it would be difficult not to make some sort of impact. And myself, I'm very positive the technology is going to have a big impact on society. Will it enhance our quality of life? This goes beyond the technology, environmental benefits, energy conservation. Will there be an impact on the quality of life of citizens in Europe?
Can Europeans see an improvement in their quality of life as a result of this? Young researcher here, now I know you're looking at stuff that might come to the public in 25, 30 years, but what do you think?
Probably depends a little bit on how you define quality of life. I mean, I definitely see that in the next few years there will be a couple of neat gizmos around which you can wear that might measure your pulse or UV exposure.
Safety helmets we've got already, haven't we? Yeah.
Nice skis which let you run down the slopes a bit quicker. So if you count this already into improvement of quality of life, then yes, for sure. But I also see quite a chance for groundbreaking inventions like superconductivity, for example. This could be a game changer. Room temperature superconductivity will change the way we distribute energy, for example. I mean, if you go crazy, you can imagine paradigm changes.
And flexible expertise there, Maria, what would you suggest is a way of looking at quality of life interests?
Yeah, definitely wearable sensors for health and well-being, and already now there has been concepts which are relying on tiny sensors based on graphene, and which are nice to wear and easy to wear, and which can be used to prevent diseases and monitor the vital parameters from
Certainly
human
monitoring
beings.
vital signs and keeping those whose health is already not very good could be a huge improvement in healthcare, couldn't it?
Yeah, not to be wired, but be still able to move and move and have fully autonomous sensors.
Yes. In our remaining few minutes then, is it possible for you all to give it, unless there's one last question? Yes, one there. Gentleman in the white shirt. Oh.
So do you think...
Speak closer to the microphone.
Do you think that in post-2023, or in terms of realization of applied technology, graphene will remain to be the predominant material, or do you think other 2D material types like molybdenum disulfonate will become a bigger proportion of the Graphene Flagship?
I think the other 2D materials are growing, in particular when, if you look at the fundamental science aspects of the Graphene Flagship, there for sure materials like molybdenum disulfide or platinum diselenide and so on, they are growing substantially. We have still not seen so much of those materials in the applied areas, but it is only reasonable to expect that they will grow in the applied areas as well. That's the route that graphene has taken, took maybe 10, 15 years, well, almost 15 years for graphene to take that route. The other materials perhaps will take something similar. Graphene has the advantage that it's chemically very nice, very stable. Some of the other layered materials are perhaps a little less nice from the chemical point of view. So they may have other challenges there, but I'm sure that they will grow.
So then finally, crazy or not so crazy predictions for where graphene or the flagship itself is headed in the next 10 years, Luca?
Ooh, that's hard to say. For the flagship, I don't know.
But for your research, maybe?
I would hope that for my research, material quality will improve. I think that will be definitely the biggest game changer, both for research but also for applications. If we manage to get the quality which we currently have in the highest quality small-scale Scotch tape devices on a large industrial scale, I think there is almost no limits to new materials which are tailor-made by stacking multiple materials, twisting them, using entirely new degrees of freedom to create artificial new materials, or even improve applications which we currently already have by just ramping up material quality.
Scotch tape devices, I love it. Maria?
Yeah, I would like to see a autonomous, sustainable, maybe even compostable or biodegradable wearable device, which would, for diagnostic purposes, and we could produce that in a large-scale mass manufacturing process, and that, of course, would be so safe that you can attach it directly on the skin, and it will rely on graphene-based electronic components, powering, and sensors, of course.
Biodegradable devices, there we
Yes.
go. Okay, Dusan?
I will stay with bulk graphene. I can see enormous progress in next 10 years combining graphene with 2D materials in area of composite materials, advanced coating, and energy storage, especially home energy storage linked with solar cells. That's huge potential where graphene can provide good things.
Solar cells, Anna?
I agree with Dusan. In our everyday life, composites and coatings with graphene, enabled by volume production.
Jari?
I think we will see considerably more consumer products with advanced functionalities. Now, of the products that Kari mentioned in his keynote, many are business-to-business products that are not immediately visible to the public at large. So I think we will see more consumer products. I predict that we will see more products in electronics when we get these reproducibility and manufacturing issues under control, which is one of the goals for the experimental pilot line. But I think that we will have succeeded if people do not raise their eyebrows when they hear that there is graphene in something, that it has become so ubiquitous that the response is, well, so what? And then we have sort of succeeded.
Ubiquitous graphene, brilliant. Thank you, Professor Jari Kinaret, Dr. Anna Motta, Professor Dusan Losic, Dr. Maria Smolander, and Luca Banszerus. And also to our two earlier speakers, Dr. Kari Hjelt and Dr. Elmar Bonoccurso, and to you for being here. And I hope you agree that the takeaway message, if there is one, is that there is still huge potential in graphene, in its research and in its industrial partnerships, and how the Graphene Flagship is planning the next stages of all of that. Thank you. Thank you. we need to